All right, so here is objective 1.2, continue translations. This is part 2. So today we're going to continue with composition of functions, okay? Before I dive into this worksheet, this last page of the worksheet, I would like to do a little side note, okay? So let me put that aside for a little bit, and let's review something important to understand. Is the word evaluate. So let me write evaluate, evaluate. What does evaluate a function means, okay, in mathematics? What does evaluate means? Well, evaluate means you want to substitute, okay, substitute a value, okay, a numerical value, for the variable, okay, for the variable, okay? So evaluate means I want to substitute a value for the variable that is in place. So for example, if I have f of x equals 2x plus 1, okay? So if I have this function, f of x equals 2x plus 1, I want to substitute a value, I'm talking about numerical value, for the variable. And then, of course, we continue by perform the operations, okay? The operations that the function is giving us, which we call this the function rules, right? So this function over here is telling me that every time you give me a value, I'm going to multiply it by 2 first, 2 times that number, then I'm going to add 1. So that's the operation, is to multiply it times 2 and then add 1. We got to follow the order of operations, okay? In elementary school, we call this PEMDAS, okay? We do parentheses or exponent first, and then either multiplication or division, whatever comes first, and then we do addition or subtraction, whatever comes first. So we have to follow the rules of operations here when we're evaluating a function. So what does evaluate means when I plug in a number? So let's go ahead and try, let's pick something simple. Let's go ahead and write the function, but let's leave it empty. Okay, I like to say that. Let's empty it out of the x value, okay, of the variable. It's 2 times something plus 1. Okay, whatever you want to give me, any number you want to plug in here, it's evaluating the function. Okay, so let's say I want to plug in a 1. So instead of x, we want to plug in a 1, f of 1. So I'm going to evaluate the function. When I plug in a 1, the first I do 2 times 1, which is 2, and then I add 1 more. So I finished the operations. 2 plus 1 is 3. If I am to write this as an order pair, okay, it would look nice to say I plugged in 1 for x and I got out a 3 for y. So 1 comma 3, okay? Let's do it one more time. What does it mean to evaluate a function? So let's do f of x. Oh, let's do the same exact function, but this time let's plug in f of x equals 2x plus 1. So it's the same exact function. This time let's plug in a 5. So first, I like to write the function without the x's, okay? Let's empty it out. I call it emptying out the function. So f of anything you want, blank for now, is 2 times blank plus 1. So these right here is the operation, 2 times whatever plus 1, okay? Let's plug in a 5. If I plug in a 5 in the place of x, the first thing I'll do is multiply, order of operations here first. 2 times 5 is 10, then I'll add 1, okay? So, and then I finish the operations, 10 plus 1 is 11. If I am to show this as an order pair, I plugged in 5 for x, and I got out, the output is 11 for y. Okay, that's what evaluate means. If you forgot what evaluating a function means, we're going to evaluate functions all the time. Okay, but that has that transfers over, that carries into composition, okay? You can see the example here. I'm going to leave it side by side. What does composition mean? So let's write the word composition, okay? What is composition? Well, composition, I'm going to substitute a function for the variable. Okay, so in evaluate, we substituted a value, okay, a numerical value for the variable. In composition, we're going to substitute a function, another function, I should say that, okay? We're going to substitute a function for the variable, okay? So I know it's kind of like, and sometimes we need to take it a little further and we needed to simplify it. Simplify if needed, okay? So sometimes we need to take one step further and simplify it. So I'm going to use the same exact function right here. I'm going to use f of x equals to x plus 1, okay? And I want you to plug in another function. So let me highlight this, okay? This, I'm meaning another function, okay? I want you to plug in a different function instead of an x. So let's go ahead and pick g. Let's label a different function, different name, okay? G of x to be x squared, okay? So those are two completely different functions. I want you to put in g of x. I want you to put in inside of f. So let me write f outside, okay? I'm writing f on the outside. I want you to put g inside of f. That's what composition means. You're substituting a function for the variable, okay? And then, so let's go ahead and write the function right here, 2x plus 1. Let's write it empty, okay? 2 times something plus 1. Just like we did it over here when we wrote it empty and then we plugged in a number. This time, instead of plugging in a number, I'm plugging in a function, okay? What is the g of x function? Let's go ahead and plug it right in here what the g of x function actually is. The g of x function is x squared, okay? So, and then I simplify it to make it nicer and cleaner. So I really don't need parentheses. I'm doing 2 times x squared. So 2 times x squared plus 1. So the new function is a composition. We say f of, instead of f of x, we say f of g of x, okay? So that is the new function. I composed one inside of the other, okay? This composition right here has several notations, okay? I can show the same exact composition, f of g of x. I can show it as f of g of x, okay? You're going to see that. It means the same thing. It means I'm putting g inside of f. F comes first, so it's the outside function. Or I can show it f of g of x, which means the same thing. I'm putting the g function inside of f, okay? So that's what a composition means. I'm putting a function inside of another function in the place of the variable that was there, okay? So I know this is just a one example. I want you to just kind of have an idea. Let's go ahead and get into the worksheet here. We go a little bit more into explanation. So let's go over the explanation one more time. What does composition of function means? The composition of a function g with f is written as g of f, okay? Because g comes first, that means it's an outside function. Let's write that down, okay? That g came first, so is the outside function. And then because f came second, that's the inside. That's what I'm going to put inside of g. I'm going to put an f function inside of g, okay? Another way to see this, g of f, is defined as, right here, g of f of x. That means I'm putting f inside of g, okay? And another way to look at it is f of x is inside of g. So g of f of x. So we can see it written in three different ways, and it means the same thing, okay? The function of f of x replaces the x value, okay? So it replaces the variable in the g of x function. So it replaces the x value. We are substituting the variable in there for another function. So function composition is not commutative, okay? So since f of g of x does not always equal g of f of x. Commutative means putting a g function inside of f is not going to result in the same new function as if I put f of x inside of g. So that's not commutative, okay? All right, so let's go ahead and take a look at this example right here. We have an example, we have f of x equals x squared, okay? And then we have g of x equals x minus 3. So let me do it from scratch, and then we'll come back and look at it over here again, okay? So I'm going to put a little white paper right here. So I have two functions. I have f of x equals x squared. And then we have the other function, g of x equals x minus 3. So we have two separate functions. Let's see what they're asking us. They're asking us find f of g of x. So from the picture here, from the notation, you can see that they're asking us find f outside and put g of x inside, okay? So we're going to put g of x is on the inside and f of x is the outside. Okay, since f of x is the outside, I am going to write f of x function, empty it, okay? F of blank, I'm writing this function right here, right now, but I'm writing it blank without x's in it because we substitute the x value, right? So f of blank equals something squared. So I always like to write the function that is outside empty of the variable. Then I can go ahead and plug in what you want me to plug in. You want me to insert g of x into my f of x function, okay? So in here, I'm going to put g of x is the name of the function. And over here, I'm actually going to put the rule of the function. And the rule is x minus 3. So I put the g function, which is x minus 3, inside of f of x. Over here's their names, okay, f of g of x, and over here's their rules. So the new function, let me write it nice and clean and pretty, is f of g of x equals x minus 3 squared. That's the new composed function. It created a new one, okay? So if you go back over here, you can see that that's what we end up with. F of g of x equals x minus 3, okay? All right, so let's go ahead and do a couple more examples to see if we understand. If f of x equals x squared and g of x equals x minus 3, which is the same two functions we gave as an example right here. Now this time, I want you to put the f function inside of the g function. So we're doing the opposite now. Instead of putting g inside of f, we're putting f inside of g. Since g is our outside function, I'm going to write g as the g function, but I'm going to empty it out, okay? So here's the g function right here. I'm going to write it, but I'm going to write it empty. I'm going to write g empty of x, take the x out, and then I'm going to leave a space. In order to leave a space, I either draw a little line, minus 3, or you can put parentheses, one or the other. I don't care which way you use it, okay? But just leave a space because you just took out the x values. You took out the variable. Now, inside of g, we're going to put the f function. Over here, we put the name, f of x. And over here, we insert the actual rule of f of x. The f of x rule is to square whatever you put in here, x squared. So that's the rule we're going to put it in here, x squared, okay? Now let's just write it nice and clean so it looks prettier. So g of f of x equals x squared minus 3. So that is our new composed function. The instruction says find, we did it, and graph the composite function, okay, the brand new composite function. So this is our new composite function. Let's go ahead and graph it, okay? The first thing we need to do is find a starting point, okay? We learned that in objective 1 and 2, okay? So let's go ahead and find our starting point. I am not doing any shift left or right to the x. This negative 3 is not affecting the x. If it was, we would have put it in parentheses, okay? This negative 3 is an outside value. I'm not shifting the x left nor right, so to show that, I put a 0. So I'm not doing any left or right shift, but this negative 3 is telling me that I'm going down 3 units, okay? So comma negative 3. So I'm not doing any left or right movement, I'm just going down 3 units. Another way to look at it is to evaluate. If I plug in a 0 in here, 0 squared is 0, and then 0 minus 3 is negative 3. So I plugged in a 0 for x, and we got out a negative 3 for y. Okay? So our starting point is 0, comma negative 3. It's also important for you to decide what kind of function we have. When I look at this, I have a squared, because of this 2 right here is a squared function, which means we have a quadratic. You can either call it quadratic or you can say parabola. It doesn't matter which word you use, they mean the same thing. So I know where to start, 0, negative 3, and I know it's a parabola, and then that invisible number right in front of the x, it's an invisible 1, is our stretch of 1, okay? So now I know all the information I need to graph my composite function. It's a parabola, and my starting point is 0, negative 3, with a stretch of 1. So 0 for x, drop 1, 2, 3, right here. And then we go up 1, we move 1 unit to the right, and then 1 unit reflected over to the left, so we can open our parabola. And there we go. We have our parabola. Is the brand new composite function, okay? All right? Let's do it one more time. The composition of function. Okay, we have the g function right here. The g function is a absolute value, okay? And then we have our f of x function, which is just x plus 2, which is a linear. Let's just think about it before we jump into composition. So we have an absolute value for g of x, and f of x is just a linear. They want us to put the g function inside of the f. So f is our outside function, okay, is our outside function. So since f is our outside function, I'm going to write f, but empty it out. I'm going to take out the x's out of the f. I don't have a lot of space to work on this right here, so I'm going to work on my blank paper here, okay? So since f is my outside function, I'm going to write f, but I'm going to empty it out. It's going to be f empty, and then you either leave a space or you put a big parenthesis there because g of x is long, okay? And then we have our plus 2. So the only thing I removed from f of x was the variable x from both sides of the equal, okay? They want me to put the g function inside. So over here on the left, I'm putting the function name, which is g of x. On the right, I'm putting the rule of g of x. What is the rule of g of x? Is negative 2, absolute value of x, plus a 1. That's the rule, okay? On one side, you put the name of the function. On the right side of the equal, you put the rule of the g of x, okay? And then we just clean it up. Remember I said we simplify sometimes. I have a plus 1 plus a 2. We can definitely do that operation. and it becomes negative 2 absolute value of x. 1 plus 2 makes it 3, okay, equals 3. So that is the new composite function, f of g of x equals negative 2 absolute value of x plus a 3. So let's write that down right here. We have the f of g of x equals negative 2 absolute value of x plus a 3. And here's my work to show how we got it, okay? So now that we have that, we can go ahead and decide our starting point, okay? So let's take a look, what translation am I doing to the x value? Am I moving the function left or right? Nope, no left, no right. So to show that in numerical value, we put a 0. I'm not moving the function nor left nor right. But this plus 3 tells me that I'm moving the function up 3 units, okay? So that's how you show it. Another way to think about it is, let's evaluate. If I plug in a 0 in here, the absolute value of 0 is 0. And negative 2 times 0 is still 0. And 0 plus 3 equals 3. So when I plugged in a 0 for here, I end up getting a 3 for y. Okay? So when I plug in a 0 for x, we got a 3 for y. Okay. Another thing that we need to decide is what kind of function do we have? We have an absolute value, right? Absolute value, which is that V shape. Okay? Then we determine, is it a slope or is it a stretch? Well, it's a linear absolute value, so our slope is negative 2 over a 1. So I'm dropping 2, run 1. Okay? So let's go ahead and graph our function. We're going to go to 0 for x, up 3 for y. 1, 2, 3. There we go. It's an absolute value, it's a V shape. Okay? So I'm going to drop 1, 2. I'm going to run 1 to the right. I'm going to reflect it over to the left so we can draw our V shape. Nice and sharp, not curvy like a parabola. And there we go. We put arrows at the end because it goes on forever. So there is our absolute value, is our composite function. Okay? All right, our last example is describing a translation. It says, graph and label f of x and g of x on the same grid. Okay, they want us to graph these two functions on the same exact grid right here. So let me put a little separation here. Let's take a look at f of x. F of x is negative 2, in parentheses the quantity x minus 3 squared. So let's first find our starting point. Okay, what should I start with? Well, if I plug in a 3 in here, okay, if I plug in a 3 in here, I'll get a 0. Because 3 minus 3 is 0. And 0 squared is 0. And then negative 2 times 0 is also 0. Okay, so when I plug in a 3, I get a 0. Another way to think about it is, what translation am I doing to the x value? Well, if you say to the left because you see a negative, that's not correct. It's to the right 3 units. Okay, and that's how I show right 3 units, by saying 3. And outside, I don't have any value, so I'm not moving the function up or down. And to show that I'm not moving it, we put it as 0. So 3, 0 is our translation of from the parent function. Okay, is our starting point. Then I decide what kind of function I have. Well, because it's squared right here, we have a quadratic. Okay, you can either say quadratic or you can say parabola. Okay? Then I decided, is it a slope or a stretch? It's a stretch. So a equals negative 2. This is not a slope. Let me write it nice and tiny, but I'll repeat this. Not a slope. So I'm not going to count it multiple times. I'm only going to count it one time. Is the stretch of our parabola. Okay? So let's go ahead and do f of x first, because they want us to graph and label. So I'm going to go for 3 for x, 0 for y. Okay? Label your variable so you're not confused. 3 for x, so 1, 2, 3 on the x-axis, and nothing for y. So we are starting right here. I'm drawing a parabola, which is a U shape, but I'm going down 2. So down 1, 2, open 1 to the right, reflect it over to the left, so we can make a U shape. Nice and round, U shape, and put arrows at the end to emphasize that it goes on forever. And that is our f of x function. I'm going to label f of x because he asked us to graph and label. Okay, now I'm going to use a different color. Let's go ahead and do g of x. G of x is negative 2x squared plus 1. Let's find our starting point, okay? If I plug in a 0 in here, okay, I choose to plug in 0 because it makes sense. It's the easiest number to plug in. 0 squared is 0. And then negative 2 times 0 is still a 0. So this whole term, 0 it out. And then 0 plus 1 is just a positive 1. Okay? Another way to look at it is we are not doing any translation to the x. We're not shifting the x. If it was, it would be in parentheses, just like this other one is in parentheses. I'm not doing any shift on the x, but I'm moving the function up 1 unit. That's why we show no translation on the x, up 1 unit. Okay, so that's our starting point. We also have a quadratic, or you can call it parabola. Okay, so we also have a parabola. They're actually the same exact functions, just in different spot, because the stretch a equals negative 2. So the stretches are the same. It is the same. It's also a parabola of the same exact stretch, same exact size. They're just in different locations. Okay, this one is at 3, 0 for f of x. This one is at 0, 1. So let's label 0 for x, y for 1. So 0 for x, and the y equals 1. 0, 1 is right here. We are dropping 2 units, just like the stretch says right here. Drop 2. You open 1 to the right and 1 to the left. And that is our parabola. Nice and round curve. Okay, there we go. Let's label this g of x because it asks the instructions, graph and label. Okay, read the instructions over and over and over. Okay, I did the very first part. Now part B says, describe the translation from f to g. So how do I go from f to g? Well, f, just pick the starting point. F is right here. How do I get to g? From one starting point to another starting point, okay? So let's go from here. I go 1, 2, 3 units to the left and 1 unit up. From one starting point to the other, I would have to go 3 units to the left, up 1 unit. So 3 units, left, and up 1 unit. It really doesn't matter the order how you say that. You can say left 3 units, up 1 unit. However you say it, as long as you say 3 to the left and up 1, or 1 up, okay? Now they want us to describe the translation from G to F. Okay, so now starting from G, how do I get from this starting point to the f of x starting point? Well, it's the opposite, okay? How do you get from f to g? Is the opposite of how you get from g to f. So I would have to go down 1 unit, so down 1 unit, or 1 unit down, and I would have to go 3 units to the right. 3 units to the right. Okay? So that's what you'd have to do. You have to go down 1 unit, 3 units to the right. So make sure you label things in your graphs, especially when you're doing 2 graphs on the same grid, because if you don't label, you'll get confused which function you're referring to. Okay? The neater you do your work, the nicer your work looks, it's easier to be able to answer these questions. All right? So good luck on your finishing your objective 2. Next time we'll do objective 3. Okay? Good job.